let's look at one final example where we put the Lorentz transformation to work. And this example is particularly nice because it shows how all the pieces of what we have been developing fit together. Okay, so what is the question at hand? We are going to imagine that a laser is at the origin of team platform. We switch it on just as team train goes by, right? The laser is firing. Team train folks, George and his friends, are looking at the laser, and we want them to calculate the speed of the laser from their perspective. We know what the answer has got to be. It has got to be the speed of light, but it's very useful to see how all the pieces of what we have developed will fit together to ensure that the speed of light is constant. It has to be that case. We've used that in our very derivation, but it's nice to see it all in action. All right, let's do the calculation over here, and let's set up our little problem. So what do we have? Let me set up a coordinate grid here in one dimension. So here we go. Let's make this the platform coordinates. Let's imagine that George and his friends are rushing by, and they are going like this at some velocity equal to v. And what happens, we are told, is that at the origin of the coordinate system, we have this little light bulb. And just as the origin of the moving frame and the origin of the stationary frame cross, the light beam is sent out. Okay? So let's then look at the two events that will be of relevance to our calculation. So what is event number one? Well, now you should have some feel for what we will put here. Event number one is that the light is emitted. What is event number two? Let's call event number two that the light, let's say that the light passes position x equals velocity of light times time from the perspective of those in the platform frame. So event number two, whatever, we can put this down here. Let's call this location x equals c times t. Now, we want to work out where and when this second event took place from the perspective of the moving frame. Again, we're going to assume that they all agree on what happens at the origin. Okay, so from the perspective of team platform, what are the coordinates of relevance to us? So, of course, we have t1, x1. We'll take that to be the origin that gets us going. And for t2 and x2, well, those coordinates, in fact, define the event itself. So t2 will just be equal to t, and x2 will be c times t, which is where the second event takes place. Good. OK. Now, let's look at team train. Let's just plug into the Lorentz transformation to work out the coordinate values that they will ascribe to the second event. So t2 prime will be equal to gamma times, well, we know the formula. It's t minus vx over c squared. What is x? X is c times t, right? So we got c times t over here. And therefore, we can write this guy out. Well, let's just leave it like that for the time being. Let's get x2 prime into the story. That will be gamma times what? It's x minus vt. And x in this case is ct. And vt is just vt. OK. So we now have the time and space coordinates according to team train of the second event of the light passing a given location. How do we use those to get at the velocity of light according to team train? Well, velocity of light, according to them, is gotten by looking at the distance that the light covered divided by the time that it took it to get there. So that's gamma times ct minus vt. divided by gamma times t minus vct over c squared. Okay, so now we can look at this equation, cancel out the gammas. Let's also note that we have a t, a t, a t, and a t that we can cancel out too. So we're left with c minus v divided by 1 minus v over c. And lo and behold, that's the same as c times 1 minus v over c divided by 1 minus v over c. Those guys cancel, and the only symbol that is left standing on the board is 1 factor of the speed of light equal to c. So it all works out just as we knew it had to. Space and time conspire in just the right way to keep the velocity of light equal to the speed of light, as it must, but it's great to see how it all fits together.